Welcome back to database training session. Databases training session. I am welcoming you back. In previous session, we have discussed about various data types like exact numbers, approximate numbers, character strings, Unicode character strings, date and time, binary strings, and we have few other data types also like cursors, SQL variant, table, XML. These are little bit advanced. So after few sessions we are going to revisit these other types of data. We discuss after few sessions. After few sessions we are going to discuss in deeper about the other types of data. So but right now we have seen so far about the exact numeric data types, approximate numerics, then date and time, character strings, Unicode character strings, binary strings, and other we are going to discuss after few sessions about the other data types. Okay, so today once again we are going to review the concepts related to RDBMS. Then after that we discuss about the SQL. SQL is a structured query language using which we communicate with database. So to get communicated with database we need some kind of language using which we actually interact with the database. So for that we use SQL. SQL is actually the language of relational databases using which we interact with the relational databases. SQL stands for structured query language. SQL stands for structured query language. But before we discuss much about SQL, let us once again review the terms associated to relational databases. Okay, so once again we are going to review the terms associated with the relational databases. But before that I am going to launch here the SQL Server Management Studio. So RDBMS stands for Relational Database Management System. So it is actually a management system using which we manipulate relational models. In 1962, in early 60s I think, the E.F. Card, he was a scientist, data scientist in IBM, proposed a model called as relational model. So mostly these days for preserving data, the organizations use relational model. So based on the relational model, different commercial vendors have developed databases. Oracle is one such database, SQL Server is another database, then MySQL is one more database. Like that we have number of databases, but these three are prominent databases. In most of the places these are used, and apart from these three, IBM too is also widely used. Okay, so in relational model we represent data in the form of rows. So we store rows in the relational model. So in the relational model data is saved in the form of rows. See, using actually this RDBMS stands for Relational Database Management System. Using that we actually manipulate relational database. So relational database meaning is it's a collection of tables. It's nothing but collection of tables, and one table may be connected with another table. So tables have interconnection between them. So tables are going to have interconnections between them. So here database is nothing but collection of tables. We may have number of tables in a database, and one table may be getting connected with another table. Depending on the requirement, normally we link one table with another table using primary key, foreign key concept. So using primary key, foreign key concept, we actually link one table with another table. So regarding these concepts we are going to discuss in detail after some time. Okay, so the RDBMS is most commonly used database. So every database may contain number of tables. Okay, each and every table may contain number of columns. So a table now, what exactly table is? A table is nothing but collection of data in the form of rows. Actually, in the form of rows and columns, data is collected and actually saved in the table. So a table is nothing but actually collection of rows. Each and every row contains number of columns. Okay, so a table is nothing but collection of data in the form of rows. You look at the Excel sheet. When you look at Excel sheet or when you look at Lotus 123 spreadsheet, we have number of rows and columns. In the left side, we have 1, 2, 3, 4, 5 like that. That is called as rows. And you have A, B, C, D like that. They can be columns. Like that, you can think the relational table also. So in the table, we represent data in the form of rows. Every row may contain number of columns. Okay, so and here, as I told you, a table is nothing but collection of records. Then what exactly a record is? A record is nothing but set of columns. So set of columns. So number of columns you may have that record. A record is nothing but set of columns. When you open Excel spreadsheet, for example, you are storing student data. When you store student data, in the extreme left you may have student ID followed by student name. Then you may have actually the subject 1 marks, subject 2 marks, subject 3 marks. So like that we have actually some data. So student ID may be in numeric format, student name may be in string format, and subject 1, subject 2, subject 3 can be in the again numeric format. So all these are nothing but columns. The first column is A, column name is A. A is actually, in the A you can keep only numeric data, in the B you can keep string data, in the column C you are going to keep their numeric data, in the column D you keep numeric data, in the column E also you are going to put numeric data. So like that, in different columns we keep different type of data. Such collection of columns is called as a row. So such rows we are going to save in the table. Such rows we are going to be saving in the say rows. So a table is nothing but collection of rows, and every row contains different number of columns they contain, and each and every column may hold different type of data. Yesterday we discussed it in our previous session. We discussed about data types. So with those types only you should arrange data in the columns. You can use any of those column types, and that type of data you can keep in the columns. Okay, so here a column is also called as a field. A column is also nothing but actually field. A column is nothing but it is actually a part of the row. Okay, so every column here it should be associated with one particular type of data. You need to it should associate with one particular type of data. So therefore, a column is nothing but it is part of row, and in the row the column is associated with one particular type of data. So it can be any data we have seen in our previous session. So using that particular type of data we can keep in the column. In the given column we can keep that particular type of data. So normally relational databases organize data in the form of relational tables. One table may be connected with another table. Okay, so the tables contain rows and rows contain number of columns. Each and every column should be associated with one particular type of data. That means in the given column you should have that particular type of data. Whatever type of data you want to put, you cannot put. So that is nothing but scheme of the table. Before you put any data into table, you need to define the schema for the table. So once you define schema for the table, you can start inserting data into the given table. Okay, so but how to create the structure or how to create a table? Similarly, how to manipulate data into that? Manipulation means you need to insert data, you need to update data, you need to delete data. So how to do all those things? So for that you require set of commands. So those commands are called as here SQL commands. SQL stands for structured query language. So using SQL you can interact with the database tables. Not only with database tables, even you can manipulate other database objects. And whenever we talk about databases. Apart from tables, it may contain number of other objects. For example, see example DB here. In the example DB, we have tables, we have views, we have synonyms, we have programmability. Here we have service broker, storage, security. Okay, so as we progress, you understand all these. But right now, we talk about actually primary storage mechanism. It's nothing but tables. All these are going to be logical. So this is going to be logical. Okay, physically data gets saved in the data file. So it's called as normally MDF file or NDF file. So Microsoft database, when you create two different files, I mean at least two different files that get created. One is MDF file, other one is going to be LDF file. Okay, sometimes what happens, you can split data into more than one data file. So in such cases, that is called as secondary data files. This is as far as physical storage is concerned. Okay, then similarly, the data, the DBMS is going to be, manipulating in the form of pages. One page is equal to 8 KB. Like that, we have 8 pages in one extent. Okay, one extent is going to be equal to 8 pages. That means what, one extent is equal to 64 KB. Like that, data is going to be here manipulated by the underlying DBMS, database management system. Okay, so physically it's going to be saved like that. But whenever we talk about table here, it's going to be logical. We say it as actually logical. So here the table is going to contain rows. Each and every row contains the rows further are divided to columns. So the columns can be some of the data types which are supported by the underlying SQL server or underlying database server. Okay, so a table contains number of rows. In rows you have number of columns. Each and every column must be associated with one particular type of data. Now to create such structure and to interact with the databases, we require some kind of language. So using the languages command, you interact with the database. So that is nothing but here SQL. SQL stands for structured query language. So using SQL, we can we can manipulate database tables. Apart from database tables, there can be many other objects like views, synonyms. Under programmability, you have here procedures, functions, the triggers. Okay, if you want to create your own type, you can create. So you can be defining your rules. So all these are possible here. So therefore, using SQL, we can do those. SQL stands for structured query language. So using SQL, we can interact with the databases. SQL is actually a standard. SQL is nothing but standard. It's not any particular software. So it is called as a standard. It is from the ANSI, American National Standards Institute, and in formulated certain standards. All these commercial RDBMS vendors, according to the SQL, they develop their own language. So that is something like DLSQL, TSQL. When you want to interact with the SQL server, we have to use, when we have to interact with the SQL server, we have to use TSQL, and when we have to interact with the Oracle, we need to use PLSQL. So TSQL is a programming language using which we interact with the SQL Server database. Similarly, when you want to interact with Oracle, we use here PLSQL. So TSQL is nothing but transact SQL. So here in the Microsoft, using TSQL, we actually manipulate databases. So manipulation in the sense insertion, updation, deletion, then similarly selecting data, or else performing many other operations also. All of them can be done with the help of SQL commands. So SQL is therefore structured query language, and as far as SQL Server is concerned, it uses TSQL as its proprietary programming language. So it is database programming language. It's called TSQL. So using TSQL, we actually invoke commands against SQL Server database. So TSQL supports SQL. That means all SQL specifications which are defined by ANSI are implemented with the TSQL, and apart from that, it has its own commands also. It has its own commands. So they are unique to SQL Server. Apart from normal SQL Server SQL commands, as well as it has its own commands, they are unique to that particular SQL Server database. So TSQL is the programming language using which we interact with the SQL Server. Okay, so SQL further we can divide it into smaller languages, that is DDL data definition language, DML data manipulation language, TCL transaction control language, and DCL, that's called as data control language. Like this we have here. Further SQL is divided into sub languages, I can say DDL, DML, TCL, DCL, and one more also DQL, it's called as data query language. Okay, so using DDL we can actually define the database objects. To define database objects we need DDL commands. So using DDL commands we actually define, we alter, we even drop. So to define some database object we require DDL commands. Similarly, to alter those objects you require DDL commands. Similarly, to truncate or to drop or even to rename them we require DDL commands. So DDL stands for data definition language, using which we actually perform definition data definition related things. So DDL stands for data definition language, using which either you create or you alter or you drop or truncate or rename. So truncation, dropping and rename also part of the DDL. DDL stands for data definition language. Similarly, DML commands. So DML are going to be with the data. So using DDL you define the structures, and with the help of the DDL you are going to manipulate the data. So DML stands for data manipulation language. So here you have insert command, update command, and delete command. So insert is basically for inserting data into the table. So it may be table or it may be view. View internally refers actually table. Okay, so you can use DML commands insert to insert data into the table or into the view. View indirectly enters data into table. Again internally view uses table only. Similarly, update, when you want to update data in the table you can use update command, and when you want to delete data from the tables you can use delete command. Okay, so these three are the DML commands: insertion, updation, and deletion. Similarly, when you want to retrieve data from database tables we use select command. Using select command we retrieve data from the database tables. So select is going to be called as here select query, and other queries, other commands are going to be called as action queries. There are two types of queries, one is select query, other one is action query. So action queries perform certain actions. They perform certain actions like defining or altering or say dropping or renaming. Okay, so or truncating, such things are done by here DDL. Okay, so with DDL we do those things, and with DML we insert, we update, we delete. So all these are going to be action only. These are called as action queries, where a select command is going to be selecting number of rows from the given table or tables. So therefore select command is called as a select query. With that you are going to select data. So you have two types of queries, one is select query, other one is going to be action query. So action query performs certain action there. It does not select any data. It performs actually certain action. So you have two queries, one is action query, other one is select query. Okay, so other type of data is going to be TCL. TCL stands for transaction control language. So under TCL you have like begin transaction, then commit and rollback. These commands we use. See, you understand these commands well when we talk about actually transactions. Transactions use ACID properties. ACID is atomicity, consistency, isolation, durability. That's part of actually ACID. They are called as ACID properties. So we use ACID properties there. So with that we manipulate actually transactions. Then similarly DCL. So in the case of DCL it is data control language. Using that you can grant permissions and you can revoke permissions. So these are going to be 5 different types of sub languages which are part of the SQL. So SQL contains DDL. Using that you bother about the structure of the database. You bother about actually creating objects, or in altering objects, or in dropping objects, or renaming objects. You bother about them with the help of DDL commands. Similarly, using DML you manipulate data in the given database. tables. Similarly with the TCL, we actually perform transactions, and using DCL we grant permissions, and similarly we revoke permissions to various users. Then here one more type of query language, that is called as DQL. Using DQL you can select data from the database tables. So these 5 are called as sub languages. One is DDL, the DML, DCL, TCL, and one more is DQL. So these different types of commands we use in the SQL. With the structured query language, we use these 5 different types of commands. So these are going to be common with all the commercial databases. Okay, so universally all the databases, they have to support it. They are going to support in them. So now let us try to look into DDL commands. With TSQL, now we use DDL commands. So here I want to first of all use a create database command. Using create database command, I can create a database. I can create a database with help of the create database command. So I give command like this. Using here the query analyzer window, I can type here commands. So using now SQL commands, I want to manipulate here databases. Prior to this, using GUI, I was creating. By clicking on this, by clicking on the new database I created last time, that was sample DB. But now using commands, I am trying to create here. So therefore, I here type a command like this: create database followed by create database command I use here. Create database followed by some database name I should give. I am going to give database name now. So I write it as first DB. I want to name it as first DB. Already if it is not existing, then it can create. It's going to be creating if the database is not existing. Create database first DB I would like to create here. So associated to first DB, 2 different files will be getting created. One is what, MDF file, other one is LDF file. And where the files are available, I am going to show you. So in the default location, they are going to be created for us. They are going to be the C drive in the program files. So where SQL Server is installed, in that location only these are going to be created. So create database followed by first DB. I want to create now database. So I have given command here like this. I have typed command create database followed by first DB. Then I select it and execute. I can select it. Then after that I execute. By clicking on this, I can execute. So what happens with that? First DB database will be created. It's going to create now first database. So command completed successfully. Here you can see the message. Now database got created. But where is the database? Right now it has opened master database. It has opened master database. Now to open first DB, you should use a command called as use followed by type here first DB. So using this you can open database. First DB we are going to open. Click on this. Now here it is opened. First database is opened. Now here you can perform whatever you would like to do. Suppose you want to create a table, you can create. If you want to select data from existing tables in the given DB, you can do. So now against this database you can perform, you can execute different types of queries. Okay, there can be DDL commands further, there can be DML, there can be DCL, there can be TCL, or there can be DQL. So whatever commands you want to issue, now you can issue. So once database is open, here you can see right now currently what database is open. You can see here. So here first DB is open for us. First DB got opened for us. Now using use first DB, I can open it. So use command followed by database. That database you can make as current database. So in that, then in that case with the database you can actually perform different operations. I created first DB. Then after that I opened here the first DB database. But where this database is created, you may be curious to know where exactly that is created. So it is created in the default location. So what is the default location for this? See here. Okay, so here I can refresh. When I refresh, it will be available. First DB is available for us. Click on this, then right click on this, go to properties. When you go to properties, it's going to open a property window. So in the property window you can see where exactly it is available. Here When you click on the files, it can show you where exactly the file is located. It is available in the program files, x86, Microsoft SQL Server, MS SQL 10_50, SQL Express. So in that you have actually MS SQL, then data, there this is available. In that particular folder it is available for us. Let me increase the size of it, and this is going to be the location. In this location it is available. So in this location this is going to be available for us. This is called as default location, and two files are associated with this. One is MDF file, other one is here LDF file. Let us see physically. For that I open the Windows Explorer. I go to here C drive, in this program files x86. I open it. So here I am going to open. Then in this we have a folder called as SQL Server. We should have here some SQL Server folder. I open this. In this SQL Server folder, okay, so here we have like this SQL Express 2008. Let me open this. Here MS SQL. Then here you have a data folder. In the data folder you can find it. You see first DB and other one is what here, first DB_log. Like this it has created for us. So first DB and first DB_log, these two files they got created. When you give simply command like this, when you simply give command like this, it is creating automatically a database in the default location. So in the default location it is getting created. So where the instance is actually installed, so in that location itself it is going to create the database. Create database first DB, then after that we have opened the database. Okay, now this is going to be first DB. I want to create here some table. It is related to some users. I want to go with a user table. I want to create a user table. Therefore I can give a command like this. Create table, command I use followed by user. Okay, I can write here users, table is going to be users, or else I write it as TDL user. If you put such prefixes, that would be really good. In the case of table, you put it as TBL. If it's a view, try to put VW. Okay, if it's a procedure, something like PROC you put, then that's going to be really a good practice. So some people they put it as USP or SP. Like that you can use certain prefixes. So prefixes they help you. Hello? Yes? So here it is, create table, TDL user. I want to create a user table. I am going to name it as TDL user. This is the syntax to create a table. Create table is the command followed by table name. Then here I should specify whatever columns I want to have in that. I would like to have certain columns. I should specify there the column names. So I want to put some column names there. For that purpose, I am going to now specify the column names along with the data type. So first thing is user ID. Every user must be having an ID. User ID I write here. Followed by it is numeric type. I put it as int. Okay. So user ID is the name of the column and int is what type of data I am trying to put into this table. In the TBL user, I want to put the first column as user ID and type of data must be integer there. It's integer type of data. I am trying to put numeric data in this. The column name is going to be int. Okay. So I have given here column name, then type of data is specified. But I want to impose certain constraints on that. So we have different types of constraints in the SQL server. The constraints are going to be, one is primary key. First constraint is called as primary key. Second one is unique. We have like this. Unique this is. Then third one is foreign key. Foreign key constraint. Then fourth one is here default constraint. So it's going to be default constraint. Then fifth one is going to be here check constraint. We have like this: a primary key constraint, unique constraint, foreign key constraint, default constraint, and sixth one can be not null. By default, everything is taken as null. That means you can accept null value. Null meaning is it's not any particular type of data, it is actually missing value. Null is called as missing value. So primary key meaning here, primary key means whatever data you enter in that column. See, whenever you take a table, in the table you can have number of rows. So every row should have same type of columns, same number of columns and same type of columns every row should have. Okay. For example, if you declare a particular column as primary key, so if you take more than one row, under that particular column there should not be duplicate values. When you put duplicate values like that, it should not allow. That is called as primary key. Okay. So in the case of primary key, what happens? Every row, see, if you take a table, you can have number of rows in that. In the table you can have number of rows. So all the rows, they contain same number of columns and same columns. Okay. So therefore, more than one row for the given column, for example user ID, you may be having some 10 rows, every row contains user ID there. So more than one row should not contain actually same value for user ID. Only user ID should be appearing once. That means in the first row, if user ID say 1000, in the next row it can be 1001, but it can't be 1000 there. So duplication is not allowed as far as primary key is concerned. Primary key always takes actually unique value, and at the same time it does not accept missing values. The values are mandatory, definitely you should enter values. So missing values are not acceptable as far as primary key is concerned. So primary key meaning is here not null plus here unique. This is called as primary key. We call this as actually primary key. So based on the primary key, rest of the columns can be identified. We can identify a row in a unique fashion with the help of primary key. So when you define a primary key, based on that a particular row you can actually identify. So this can be basically row identifier also, I can say. Based on the primary key, easily you can identify row, and rest of the columns also you can identify based on the primary key. So this can be a constraint. Now similarly, we have a unique constraint. So in the unique constraint, here data must be unique but can be null. Here. So when there is no data available, it can be null, because null is nothing but missing value. Value can be missing, but whenever you enter values, so the values must not be duplicated. That means what? In more than one row under same column, you should not have same type of data. So it should be unique. If data is missing, fine, no problem. But when data is available, in such cases, it should not be duplicated. So that's what exactly unique constraint is. Then you have foreign key. So using foreign key, you can maintain referential integrity. You can maintain referential integrity with the help of the foreign key. For this, see, I give an example. I am going to give an example for the foreign key here. See, I have a database related to employees. There are two tables associated with the database. One is what? Department. Other one is employee. We have here two different tables. One is department, other one is employee. So when you look at the department contains actually department ID and department name. And as far as employees are concerned, you have an employee ID, employee name and department ID. So here we have a department table and we have an employee table. So whenever you talk about actually department table, here in this we have DEPT ID, then you have DEPT name, then other one is you have here DEPT ID, DEPT name, these two things you have in the department. Okay, similarly when you go to employee, it may contain like here EMP ID, then EMP name, then similarly department ID. Like this you may have data. So you have two tables, department, this contains department ID and department name, and when you look at employee, employee ID, employee name and department ID. So I have these departments are going to be something like this. I have 100, that is department ID, followed by accounts. Okay, accounts department. I have 110 followed by here marketing. Okay, so one more thing is what I have 111 followed by here HR. Like this, I have 3 departments. Now come to the employee. So in the case of employee, this is for the departments. Now I am going to take data for the employee. So in the case of employees, I may give something like 1000 employee ID followed by employee name is ASR. I put like this. Then here department ID I can put 100. That means what now ASR belongs to accounts department. Similarly take 1001. Okay, then I put here ABR. Then here I can put something like here 110. That means what ABR belongs to marketing. Now I will write one more set of data like this. AKR I put here. Then here followed by, if I try to enter something like 120, it is not acceptable because there is no such department like 120. Whatever departments are there, for them you have IDs like 100, 110, 111. But whenever you try to put 120, this data will not be accepted. This is called as here referential integrity. And here department table is called as primary key table and employee is going to be here foreign key table. So we link department ID with the department ID of employee, we link with the department ID of department. So whenever you try to insert data in the employee table, if you try to enter any ID for the department ID, that should be existing already in the department table, otherwise it will not be taken. Okay, if you don't have any value, department ID in the employee table can be null, but whenever you try to enter some value, the value must be already existing in the department table. So this is called as here referential integrity. This is called as referential integrity. So sometimes we use this constraint also. Okay, this is called as here foreign key constraint. We call this as foreign key constraint. So we call this as here foreign key constraint. Okay, so similarly we have here default constraint. In the case of default constraint, see, we may forget sometimes to insert a value into the columns of the concerned row. So in such cases, automatically it should take a default value. So for that, we can define a default constraint. So this primary key, foreign key, unique constraint, default constraint, all these are called as IO constraints. But as far as check is concerned, domain constraint. This can be called as here domain constraint. So with the help of the check constraint, you can be validating data for the given domain values only. For example, you try to enter in the employee table, you may enter information related to employee like DOB. DOB, you have to enter. Date of birth, you need to enter in this. So when you enter date of birth, here whatever data you enter should not be taken, because whenever you try to take an employee minimum age must be 21 years. Okay, employee name minimum age must be how much? 21 years, and maximum age must not be greater than 58 years. 57 is you take. So it should be minimum say 21 years and maximum say 57 years. So whenever you try to enter any date of birth, if it is actually falling below 21 years and or if it is greater than 57 years, it should not be taken. So in such cases, you can use the check constraint. Whatever date of birth you enter, so that should be the current date and time with the date of birth. When you compare, the difference between the two things must be greater than or equal to 21. Okay, so the current date and time minus the date of birth what you enter, that should be giving you a value greater than or equal to 21. So in such cases, that record can be added. Similarly, you take the current date and time and DOB, if you take that value also, if it is less than or equal to 57, in such cases you accept, otherwise that row you are going to be rejecting. So that is called as check constraint. So check constraints are called as domain constraints, and domain and the values of the given domain values, it's going to be working. So we can use check constraint also sometimes. And not null meaning is you need to enter value for that. When you mark a column as not null, definitely you need to enter some value. That can be duplicate value, triplicate value, no problem. But what happens? You need to enter compulsorily data for that column. That's called as not null. So therefore, these constraints we use very much. Whenever you define a table, we are going to use these constraints. Now here in this example, we are creating a user table, user ID, int we have used it, and user IDs must be unique. No two user IDs must be same. So therefore, you need to enter primary key. At the same time, you should not have missing value for the user ID. You should not have missing value for user ID. So missing value we represent in SQL server as null. So when you put null, it means what? It's a missing value. So therefore, here I am going to mark it as primary key here. I put it as primary key. This is here primary key. User ID, int, primary key. Then followed by I should have a user name. I write like this, user name, and this is varchar of say 100. I can put char also. Okay, but instead of putting char, I can put varchar. The difference between char and varchar is what? Char is fixed length, varchar is going to be variable length. So every employee may not be having same number of characters. For example, one employee may have only 4 characters, another employee may take 40 characters. So therefore, here for username I have taken it as variable length. Maximum up to 100 I can put here. Up to 100 maximum I can put. So username varchar 100, and username is a must here. Username must be must, therefore I put it as not null. Definitely a value must be entered. We need to enter a value for the username. Okay, username, for that we need to definitely enter a value. So therefore username varchar of 100 not null I kept there. Then after that, further what I do, I am going to put here date of birth. So I put here DOB, date of birth I put here, followed by date, time. Like this I can take. We have seen there are different types of date, date related things. We have date time 2 we have there, date you have, time we have, so small date time we have, like this we are taking it, DOB, date time I have taken. Then followed by here, this is also must, this is also compulsory. So therefore what I put it as not null. Again I am going to put it as not null. We must enter date of birth. If you keep this null value, it's meaningless. It's going to be meaningless. So therefore this way I enter. This is what user ID int primary key, username varchar 100 not null, DOB date time not null, and gender also I want to take here. Now I would like to define a gender. Gender, this is char of 1. I can use just only one character because here either it is male or female, like that you need to put. So here default value I put it as male. Here default equal to default, followed by I put this as here m. Like this I can put a default value. I am keeping here a default value. That means if you forget to enter any value, automatically it's taken as m there. So create table, DDL user ID int primary key, username varchar of 100 not null, DOB date time not null, and gender is going to be here just one character. Gender char of 1, default value is going to be m. It's going to use m as the default value. When you forget to enter any value for gender, it takes m. Okay, so these are the columns I have created. Then followed by here, I may enter some password. I may enter some password also. Password I put here this way. I am going to put like this password. So this is password. Here it is varchar of say some 20. Up to maximum 20 characters we enter here. So varchar of 20, and here again this is not null. We have to put this as not null. So we need to enter a password also. It's must. Without password, it is not going to accept. Definitely you must enter a password. Then after that, I want to go with certain description. Description I would like to put here. So therefore you write it as description. Like this we put here description. We are making it description, followed by here specify this as just descript only put. Here it is varchar of say some 512. Up to 512 characters we can enter. So like this I want to create a table. I am going to create a table like this. Once again look at the table. When you look at table once again, we have in this total how many columns? User ID is a column, username is a column, DOB is a column, then gender is a column, then one more thing is password is a column, descript is a column. Like this here we have 5 columns in this. six columns we have in this. One is user ID, username, DOB, gender, then password. One more thing is descript. But as I told you, DOB minimum 18 years of age is required to become a user. So minimum 18 years age is required to become a user here. So therefore we need to put certain constraint in this. Let us try to define a constraint. Now I am going to define a constraint like this. Put here constraint followed by, write it as constraint name. So using constraint keyword you can define constraint. At the table level we are going to be defining here constraints. Put it as constraint, then here write like this. We are going to write in this way constraint, then followed by name of the constraint. CHK we put, it is DOB, like this you write. So DOB user DOB, put like this. Followed by here it's a check constraint, type like this check, then here you can define it. So the current date and time, the DOB whatever is entered, you should compare with the current date and time. So based on that we need to do it. Now here write date diff. So here interval we need to use. Years I want to use in this. Interval is going to be here, year I use. I can put year, then followed by starting date, ending date. We need to go with the starting date and we need to go with the ending date. Here starting date is what exactly? DOB, and ending date is going to be here date time. This is we take actually get date. So using get date function you can get current date and time. Like this we take. So this must be here greater than or equal to 18. So in such case only it should be accepted. So like this I am trying to impose a check constraint. Date diff is going to find out the difference between the two given dates. DOB is what you entered and get date is going to be from system it can generate. It gives you current date and time. So the difference between the date you entered and current date and time, if the difference between them is greater than or equal to 18 years, in such cases row is accepted, otherwise row will not be accepted. So like this we have defined here a table called as DDL user. This contains a user ID, a username, then here DOB, gender, then it is password, descript. Like this you have here. Okay, so these are going to be 6 different columns, and here the DOB is going to be holding date and value. You must enter data, and if the age is less than 18 years it does not accept. So like this we are going to define the table. The table name is what here? DDL user. So once this is completed you can select and you can execute this. Select this and execute here. Command completed successfully. The database name is what here? FirstDB. Let us go into FirstDB and see in this. So refresh this here. After that expand the FirstDB here, and when you expand tables you get the table name DDL user. Further you expand, you can get columns like this. We have user ID, username, DOB, gender, password and descript. Like this, how many columns total available for us? 6 columns are available. You need to enter user ID, it's compulsory. Similarly, username also we must enter. The DOB also we should enter. Gender, if you enter or not, it's okay. But if you don't enter, automatically it takes M. M is nothing but male, it takes automatically. Then password, definitely you must enter here because it's not null. Password can be getting repeated. More than one user also can be having same password, no problem. But password field is compulsory, you must enter that. Similarly, the description, if you want to put description you can put, otherwise you can omit it. So it is actually, it's going to accept null value. So like this here we have defined the table. So create table DDL user, the user table is going to contain 6 columns. Like this we have created the table. We create a table like this. Now let us try to insert data into the table. Let me insert data into the table here. So for inserting data into table I can use insert command. So this is what exactly DDL command. Create table is a DDL command. So using create table command I created here table. So once table is created you need to put some data into that. So for that purpose you have to use insert command. So insert into, I use like this. Okay, but before that let us see the structure of the table. I want to see the structure of table. Here you can see using GUI the structure, but I don't want to use GUI much, but without using GUI, with command only I would like to see. So therefore here write exec, an existing procedure I can call sp underscore help followed by table name you specify here, TDL user, specify like this. exec stands for execute, sp underscore help is a predefined procedure. A procedure is nothing but just like a program, small program. So further you are passing parameter TDL user. So when you pass like this, it's going to display the structure of the table. So table TDL user is going to be the name of the table here, TDL user. So the table user table structure is going to be displayed here. We give exec sp underscore help followed by TDL user. Now select it and execute. It's showing like this here. It's showing you this way, column name user ID, type is int, then followed by length is 4, then username, DOB, then gender, password, description. And one more important point you can see here, it does not use any collation. For numbers we don't have any collation. Username is varchar. For this we are using SQL Latin 1 general CP1 underscore CI underscore AS. So CI stands for case insensitive. Whenever you search data, it does not bother about the case sensitivity. Whenever you are searching data, it does not differentiate between uppercase and lowercase. As far as case insensitive is concerned, if it is case sensitive, in such cases definitely it actually bothers about the uppercase and lowercase. So it's going to differentiate between uppercase and lowercase if it is case sensitive. But here it is what case insensitive. It's going to be case insensitive. Username is case insensitive. Gender is case insensitive, even password is case insensitive here, descript is also going to be case insensitive. So like this here the columns you have, then followed by, there is no identity column in this. What is identity we discuss later on. Then followed by here, what are the primary keys we have in this? There is one primary key, user ID is going to be here, primary key. The name of the primary key is here, the constraint name is pk underscore tbl user underscore. It is having some ID here. In the hexadecimal notation it is shown. So this is what exactly primary key constraint. Similarly we have a check constraint, the default constraint like this we have here, and the primary key constraint becomes automatically, it's going to be created as clustered index. There can be only one clustered index available in the given table. You cannot have more than one clustered index per table. So primary key automatically creates a clustered index for us. Indexes, they improve performance of the table. So performance means whenever you try to retrieve data, if the data is indexed, data can be retrieved quite fast. So if they are not indexed, it takes a lot of time. So therefore here what happened, it is created as a clustered index. The user ID is going to be here, clustered indexed actually. So this is also here primary key. Now we create a table. This is showing here for us the structure of the table. exec sp underscore help tbl user. When you put like this, it's going to display the structure of the table. It's showing you table structure. Fine. Now let us try to insert data into the given table. Let us insert data into table. For that we use insert into. The table name is here TDL user followed by whatever columns you want to enter, you can specify in the parenthesis. If you want to enter data for all the things, you don't require any column specification. Straight away you can use values and try to insert. This is called as here implicit mode. It is not explicit mode, it is implicit mode. In the explicit mode, in whatever order you specify columns, as per that only you should enter values. But here this is going to be implicit. That means whenever you declare table, in whatever order you define the columns, in the same order values you must enter. First thing is what? User ID we need to enter. User ID is going to be numeric. Enter 1000 here, followed by username. You need to enter some username here. Username is SQL 100. I give some name. SQL 100 is going to be username. Username is what? It must not be null. If it is null, it does not accept value. you need to enter here database, date of birth. We need to enter date of birth. Date of birth must be always, it must be, whatever date of birth you enter, it is going to be checked against current date and time. If the difference between the two date times is greater than or equal to 18, it accepts. So therefore I enter this way. So first enter month we enter, followed by day we enter, then followed by year we enter. Or else you can enter first year, then followed by month, then year. You can enter like that. Now let me take something like 1995, then put hyphen here, followed by 06, and here 01, like this we enter. This is going to be date of birth. 1995 0601, like this I enter the date. Okay, the next thing is gender. If I don't enter gender, it takes actually M, but here since you are doing in the implicit mode, all the column values you must enter. So enter this as here M. You can put like this. Next thing is what here? Password. You need to enter some password. I enter this as 123456. Like this I entered password. Then followed by here description. I can put some description here. Description can be, this is the first user. This is the first user, like this. We put some text into this. After that, close the bracket, then try to insert data. We can now insert data into the table. So go to home, then execute. This will be inserted. One row affected message we are getting. What happened here? One row of data is added to the TBL user. Now come to this, then see, select star from TBL user. When you type like this, it is going to show whatever data is available in the table. Let us see, it is showing here one record. Just one record is shown. Okay, so it is taking DOB as 1995 0601. Now I try to enter one more also. I try to enter one more data. I copy this, then try to enter like this here. I try to enter again 1000. I want to repeat it, but here I just want to go with the 200, and here also I just want to put this as some 2000. I enter this as 2000 here. What happens to this C? This data must not be accepted. This is the second user try to put. This data must not be accepted. Reason, already we have 1000 as a primary key, 1000 already available in the given table. Okay, once again if you try to enter one more 1000 value under user ID in the next row, that is going to be duplication. So it must not be accepted here. Let us check whether it is getting accepted or not. Come to end, then execute. It says here, violation of primary key constraint. Since you are trying to enter a duplicate value, it is not accepting. Now change it to 1001, try to enter. So now also it is not going to be getting entered. Reason, we entered DOB as 2000 0601. 2000 minus 2016 is going to be only 16 years. But we should have actually 18 years gap. So try to execute once again this. This time you are going to be getting another error. It says the insert statement conflicted with check constraint, because here the difference is how much? 16 years difference you have. It should be greater than 18 years. Now let me put this one as 1997. What happens with that C? I put like 1997, then try to execute this. Okay, let me execute this. This time it has been inserted. So constraints actually, they restrict data. So if it is valid data, then it is going to take, otherwise